Hi, I'm Mike DeWigo. I've probably met most of you already throughout the 2 days, and this is kind of a fun exit presentation for the conference that I did originally for Java 1, the very last Java 1, back in 2015. I had just at that time left Oracle and had joined Liquid Robotics with to work with James again. If you've been to an Oracle presentation, you know that they always begin with a safe harbor statement, which is the Sarbanes-Oxley declaration that you shouldn't make stock buying decisions based on what you find in the presentation. So I changed it up with a safe harbor statement that is a little different, which is a picture of our harbor in Kauai on the big island of Hawaii. And up in the corner here is our actual facility. It's a safe harbor. So what we're going to talk about is that I've had some experience over my career working with some really interesting and exciting people, and I've worked with James on a number of different projects, early stages, and I probably had more exposure to his code than anybody else just by good fortune. And I think that James uses Java in an interesting way. It's kind of odd situation to be in, to be a person using a programming language that you wrote. That's not something that many other people can say. There's probably only a couple dozen that are using popular programming languages that they wrote. So what James does with Java is kind of interesting. So what this is not about is providing any necessary insights. Some of these things are just presented because they're interesting or entertaining rather than providing any deep value. There's not really any or much advice here either. It does explain why some of the things that you may have seen in Java are the way that they are in a few cases. I'm not telling you to either do what James does or to look at, point out James's crappy code. We all have crappy code. James wrote crappy code too. I'm not going to bother showing you any examples of that. I'm more focused on the stuff that's interesting. So what are the projects that we're talking about that James and I have overlapped on? One of them is the Java class libraries. Those began back in 1991, and James actually wrote a fair bit of the early class libraries in a couple of areas. I worked on the Oracle team. I was the collections lead through the latter half of Java 7, and then all through Java 8, I did the integration with all the collection classes and streams lambdas. So in many ways, I was kind of the first user of the lambda streams, or the lambda features and a lot of the streams implementation. And so I didn't overlap with James, certainly working on the JDK. He hadn't been working on the JDK for decades already at that point. He had moved on to other projects. Other interesting projects that we worked on was the Shelley autonomous vehicle. This is the vehicle that climbed Pikes Peak independently, one of the early autonomous vehicles. And one of the things that James was working on was a prototype to convert MATLAB Simulink code, which is what the researchers wrote in, to run it in Java, and we would run it on the Java real-time VM rather than the MATLAB environment. The intention was it would be much higher performance and much more reliable than running on MATLAB. As it turns out, the developers or the researchers weren't terribly interested in this because they were researchers and not production people. And the idea of having to compile their code was non-compelling to them, despite the fact that it would have things like interpreter hiccups while the car is driving. GC fault while you're driving down the road. That was okay to them, but they were interested in collecting data about skid performance and things like that, and driving controls, rather than making something that was production. The part that I was working on, again, because they weren't much interested in anything other than their research, was the safety system for the car. This did all the logging, telemetry gathering, GPS position management, and it also had the auto stop shutdown if something was going wrong. So it was the dead man switch if their MATLAB code crashed, which happened fairly regularly, it would bring the car to a safe stop. Basically, it would apply the brakes progressively as it slowed the car down while keeping it on the most previous trajectory. Oops, sorry, I missed the preview. So the next project I worked on with James was the one that he started right before he left Sun, which was the Java store. He wrote a prototype catalog. This was an app store type thing for Java apps, and then I was brought in to help turn it into a production product. And I did a lot of the back-end software as well as the app ingestion part where publishers would ingest their app, add all their metadata, etc. The coolest and most recent project, I think, is the Liquid Robotics Wave Glider, which I'm still working on. James moved on about 2 years ago to Amazon, about around the same time we got bought by Boeing. He was less inclined to work on defense applications than most people. That's a personal choice that people make. Even though we're not weaponized, all we do is listen for submarines and things like that. That was still too close to defense for him. He originated the project back in 2011, and the part that I was brought in to work on was the core infrastructure, things like loading plugins, logging and telemetry again, and then I did some sensor integration, and I did all the build and tooling work. They had a very primitive Maven environment where kind of everything was in one project. I split it up into multiple modules and introduced CI, continuous testing and code coverage and lots of other non-prototype best practices. So some of the things that are basics about the way that James codes, he's been a NetBeans IDE user almost 20 years now, back since around 2000, 2001. Even though his history is working in Emacs, he very quickly saw that a language like Java was much better suited to an IDE environment than to something like Emacs, and he uses things like the refactoring tools extremely aggressively. A plain old text editor just wouldn't suffice for the way he wants to code. Because he's kind of worked mostly in the forefront of technology on projects where he's the originator of them, his Java code is pretty idiosyncratic. He doesn't have the experience of working with a large team that has coding standards and that there's cross-pollination of other developers to develop a common style. Instead, the style he writes in is kind of what he has come up with himself and has evolved over the years. And he writes a lot of code that, even RSI surgery was kind of incapable of stopping him from writing code. You're supposed to not type for like 5 weeks after getting your tendons adjusted, and he had a voice dictation system up within a few days because he just couldn't stop reading and writing code. He really loves the new Java features and is completely up to date on using the latest Java. It's not like he, you hear people that's like, I'm still using the last version I worked on of some technology. Nope, he's perfectly content to let other people continue to build an advanced Java and is happy to use the fruits of it. Which I was kind of really happy to see, that he wasn't kind of a stuck in the past kind of guy. Now we'll actually get to some code. So this is a routine that James wrote, and as I mentioned, he doesn't write a whole lot of comments, but there is one comment right here, and it says, bizarre Boolean is correct. And what do we got here? We got part equals 0 equals P is deployed. That's pretty weird. Well, what does this function do? It's supposed to list the set of plugins that are installed in the environment and whether they're currently deployed or not. And the way it works is that it actually has an outer loop and an inner loop. So it iterates the list of plugins twice, once with part equals 0 and once with part equals 1. So the sense of this Boolean changes on the first versus the second loop. So in the first loop, you get all of the running plugins, because this expression will be true. And on the second pass through, you get the non-running plugins. And you end up with a single list of the running ones followed by the non-running ones. The way most people would do this, of course, is to just code this inner loop logic twice, and not do this kind of cool thing. But this is, I can't think of anybody else who would write this code this way. But that's the way he likes to do it. He has a bunch of his own libraries. Most of his stuff is not just kind of one big application or a monolithic thing. He'll divide it up into libraries, and he's got a bunch of personal libraries that he's carried around for years. There's a mix of things in them. Some of it's stuff that's custom to him, the way he likes to format numbers, or utilities for formatting currency, that kind of thing. And some of it is now obsolete, but he's got a large code base like everybody else of stuff that points at this legacy stuff. As some features have appeared in Java, features that he had written into his own libraries are now obsolete. An example would be something like string join. He had a thing that took a collection or an array and joined the items with a delimiter. That's been around since Java 8. He hasn't gone back to bother to refactor all of his existing source to use that, but in any new application, of course, he would probably use the Java 8 features, stream collect with joining, etc., rather than this legacy library. One thing that you'll see is customized versions of some of the Java classes. An example would be unsync buffered output stream and input stream. So these are versions of buffered input stream and output stream which eliminate the synchronized keyword. Essentially, they're exactly the same version or exactly the same code as some old version of buffered input stream, output stream, but they omit the synchronized keyword that is present on the current implementations. And that was done for performance in older versions of Java that didn't have lock elision. So the old JVMs, if it ran into the synchronized lock, it would go to the trouble of actually executing the lock whether the object was contended or not. Modern JVMs, they just do a compare and swap on the first thing to lock. So they do compare null and then add their thread ID for the first thing to lock, which is very cheap. You wouldn't bother to make a whole code implementation just to avoid that one compare and swap. Anyway, it's an example of some stuff that is variations on existing Java libraries. And then there's a lot of weird math stuff that he has. He does have a mathematics PhD, and his PhD thesis was in the symbolic computation of mathematics. So he has some really esoteric math stuff that he carries around with him for doing all kinds of math manipulations. We saw that in the robot for things like course plotting and some graphics visualizations, drawing of curves, that kind of thing. He also uses a style which is a little bit unusual, which he uses more recursion than most people do in Java these days. So he's got a class here that, or an implementation here that recursively reads an array. So each of the array items could be a bit more JSON. So it's reading in a JSON array, but of course every one of the items could be a JSON object or another array. So he does recursive traversal in order to read in the entire array. And there's another, what was I gonna? What was it? What was I gonna show here? Is it, oh, it's the allocation. Okay, so one thing he does is in his array reading routine is that he doesn't allocate the array at the beginning, or doesn't use the technique of using a list and then turning it into an array at the end. Instead, he recurses all the way down. When he finds the end of the array, he knows how long it is. Then he creates the array, and then on the way back up, he actually populates the array. People find that very strange. As it turns out, this is his original implementation of it, and this is the one that I had to write, because when it tried to read in an 8,000 element array with all this temporary data, it just blew the stack completely. So I had to write a non-recursive version of it if the depth got too high, so that it didn't just explode when the array being read in was unusual. People make mistakes, James included, and this is an example of a routine that he has in one of his libraries. And what it's designed to do is to read a parameter from an HTTP request, a servlet request, and if it's not available as a parameter, it'll also read it from a part. And if neither are available, it'll use a default. Well, there's a bug here, which is that if the parameter is found, then it returns the value of the parameter. If it's a multi-part request, then he'll get the part for that same key. And if it's not found, then he'll return null. But he doesn't actually use the default. So he returns null rather than the default if the thing was multi-part, but the specific key was not found. It turns out this is a bug I had to fix twice. Once in the Java store, and then again when I came to Liquid Robotics, and he hadn't noticed. But other people who tried to use his code ran into this particular behavior. Some of the contributions that James made to the Java libraries would be the Java util date class, which everybody hates, and I'm going to talk about one aspect of it. Other parts were some things that not a lot of people use, like piped input stream. He uses it fairly, or used to use it a fair bit in his older code. A lot of people can't get their head around the fact that you need a second thread. But he's fine with that. He uses stream tokenizer a lot. He doesn't use regular expressions as much, though he's moving towards regular expressions instead of stream tokenizer. And he's also wrote some portions of the Java libraries, or the java.net libraries. And where that came in was the hot Java browser. So at the time, we saw in the little demo earlier this afternoon, the Star 7 device that he was working on that kind of originated Java. And besides writing the initial language and original compiler, the component that James was working on was the browser. And so he ended up writing a lot of the networking, higher level networking classes. So not necessarily the socket layer, but all of the URL connection, and connection handlers that, if you even use them today, unless you've switched to the new HTTP client, those were retained all the way through until the appearance of the new HTTP client in Java 11. One point about that Java date class, I mentioned that it wasn't by intention mutable at that time. And the reason is that he wrote it only for the RFC 822 parsing that was needed by hot Java browser. He had no intention that would be a public API used by other people. It's an interesting story that the same thing happened with the date time classes in the C library. People complain about the fact that they have memory leaks and handle mutation in a weird way and are different than the rest of the C libraries? Well, the reason is because they were brought into the C library because somebody found the source code for a date time class in somebody's home directory in the days when Unix had no file permissions. So he just went scarfing around the directory and found a date class and started using it. And you can't really blame the author of that file for their design because it met their needs. It was never intended to be the date class for the entire runtime environment. So, it's okay to forgive James for his implementation of date. That wasn't his intended purpose. So he did work on Hot Java Browser. He also builds rich clients. We at Liquid Robotics have a JavaFX app that we use for vehicle piloting for many of the same reasons that like those NASA JavaFX tools exist and other rich client tools, because it's just too heavyweight for a browser. The earlier version that we had was browser-based with kind of a base plane by Google Maps and then adding additional layers on top. But if you want to do complicated tracks, data, data sampling or graphical overlays, the web quickly becomes or web visualization quickly becomes a problem, because for things like level of detail in SVG, how you handle that is not, unless you're doing it statically, is not handled great. So rich clients are what we use for all of our data intensive applications. For things like monitoring, systems monitoring to make sure that the back end is working okay, or we have fleet monitoring tools where you can put alarms on, like, tell me if any vehicle in the entire fleet's battery level drops below 500 watts. Yeah, we do all those as web apps. There's no reason to make rich client things for that kind of stuff. But if it's data intensive or very high bandwidth, then we're going to use a rich client app. Talk a bit about the Java store, since we're talking a bit about web apps. This was a basic HTML site that James built and was intended to exist primarily so that it would be search engine indexed. So that Google would, if you were searching for a Java solitaire app, Google would have indexed it so that you would find it, rather than having to go to to know that you had to go to the Java store in order to do the search there. A rich client app would be at a deficit in that regard. However, we did have, in parallel to the HTML site, a rich JavaFX app which was used for previewing and video. Most of the things that it was doing you could achieve today in HTML5, but this was in kind of circa 2008, 2009 era. So there were a lot of things like translucent effects, rounded corners, carousels that were harder to do in HTML at that time. So a rich client app made sense to give kind of users the best WYSI experience that was possible. We also generate HTML for the user interface for actually controlling the robots. And this was again originated by James. So this is actually a web server that's running on the robot. We actually run Jetty on the robot, and you're viewing pages that are actually being served by the robot. This is much better for field ops people and manufacturing than having to use SSH command line or something like that, which is what we do for development. We do a lot of that, but if you want to do something like turn a plugin on or off, web UI is much easier, and it's also used for a lot of kind of diagnosis purposes. It's not used as the primary interface for the vehicle. That would be the piloting tools on the shore side, because most of the time the vehicles are out of cell range and you can't use this web user interface, but this is kind of the maintenance interface to the robots. So how do we generate this HTML? Well, James, of course, has his own HTML library, which is different than anything anybody else has built, and it generates HTML from Java code. So rather than something like JSP, which is basically templating based, instead it has a HTML class which generates a page. So output the head stuff, and then output any specific head text, the names of CSS files, or output the CSS. If there's any scripts, output the HTML that's needed in order to include those script files. And it generates regular HTML. So this is the main function for generating an entire page, and we'll look at some code for, sorry, that's just a blow up of the same code I was trying to show you there. Here's a page that lists that plugins. This is actually what calls that first example we had of list plugins. So it will do things like, this is a body, so it makes a table, and then it makes a table row, a table element, and then the name of the plugin, starts a new cell, outputs in italics, outputs in bold, and then when he's done, like the individual cell, it'll actually pop the closing element using an end. So this is kind of a very idiosyncratic way to generate HTML code. I find I actually kind of like it. It's kind of weak in certain ways, but it's pretty powerful in other ways, in that it's really hard to write malformed HTML using this particular approach. And I've been looking for a web toolkit that has kind of a similar idea, where you're thinking of what you're trying to generate at a logical level rather than the exact HTML that's output. But I haven't found a toolkit that kind of has that particular approach. If anybody knows of one, I'd be curious.
I think there was something called like the element construction kit or element construction set. What's that?
I haven't heard of that one.
20 years ago or something.
Yeah, I don't know. I mean, I don't know how it would fit with current client-side generation. This is certainly not how anybody's generating HTML today. The rich client applications that we use are all REST JSON type applications. They were Swing WebStart originally, using Gluon's map component, backed by Google Maps. We've since moved to JavaFX, mostly because it's easier to author the app in JavaFX than it is to do it in Swing. Swing is kind of more banging with a hammer than doing layout, and styling is much more manual in Swing, versus JavaFX, which is primarily CSS based for styling, which we like. And compared to the previous web app, we're now doing a lot more data here. So for example, the thing that's really difficult to do in a web app version of this is when you zoom in on this particular section of it, you're looking at tens of thousands of data points. So this ends up being a visual summary at this layer, and then fully detailed at the lower layer. And then, multiple other, these are all the other boat traffic that are happening in the area, and you can turn those layers on and off. You can, look at things like, add layers for things like water temperature, wind speed. We have ones for cell phone coverage to know where in this operating area that the cell plan will actually work. So if you need to talk to a vehicle, you can say, go over there so that I can actually get a hold of you. Sure.
Sorry for interrupting. But this particular component, James did talk about this a few years ago, Java 1. Yeah, that mentioned all the capabilities you said that they go beyond what Gluon provides with its map component.
Yeah.
He said it might have been an option for Liquid Robotics to open source the component. Did it ever happen?
No, it never did that I'm aware. It hasn't happened that I'm aware of. The amount that we're using that's custom relative to Gluon has gone down over time as Gluon has become more capable. And as far as I know, the only part that we really still maintain ourselves is that level of detail and summarization component. But that kind of depends on our back end. The particular way it does that summarization of the data is dependent on how the component works, so that we would have to convince people they would have to do summarization in the same way on the back end in order to make the component useful, and that hasn't been something we've done so far.
Thanks.
You've probably seen this pattern before of creating an anonymous class in order to initialize a map. It's very much not recommended anymore, particularly since Java 9 came out with the small collections or small immutable collections. But the very first place I ever ran into this idiom was in James's code for the Java store. And as far as I can tell, he's been was using it for about 15 years. He no longer uses this pattern like everybody else who stopped using it finally. But I thought it was interesting that he appears to have been one of the first people using this pattern long before it became badly popular. It turns out that there's one thing that's worse than this map initialization pattern is to do it with a lambda. And some guy decided he liked this particular syntax of a fake parameter, which isn't actually used. Oh no, it is used. It then actually gets the parameter name and maps it to a value. This is kind of absolutely horrendous abuse of Java by somebody else, not James. He's not a big fan of databases. For most things, he'll just use the file system, often flat file, and just suck the entire database into memory. The argument generally is that for things that are non-system of record, like let's say your customer account balance, why use a database for that? If it's something small like the list of account types, just put it in a file and populate from that. In the case of the robot, we still use file-based databases along the type that were used for the Java store as well, but we use them in a different way, which is that whereas the databases in the Java store were all fairly small things like the available products or categories or user types or user roles, permissions, that kind of thing, we actually use the file system for storing the actual telemetry data received from the vehicle. But these are treated like log files in that they're kind of write once in one direction. You never go back and re-edit them. So our database of record for all of the telemetry data which comes in is just stored in the file system. We do process it into Mongo as a query environment for doing things like GIS queries, like show me all the records that are in this geographic area or for a particular vehicle. We certainly don't use the file system for searching, but our system of record is just plain old files. If Mongo gets blown up or we decide to change to a different database, well, we'll just re-import all that data, and all new data that's coming in is still just going into raw files in the file system. That makes things like backup very easy. And because they're non-changing after the day is over, or after the time period for the file is over and it rolls over to a new file, we know that file will never change again. So we can do things like hash the file and then do, if we're not on a file system that provides that scrubbing automatically, we can do it where we just check the file hashes to make sure that they're valid, and keep a registry of file hashes around. Some other idiosyncratic things. James hates printf. The reason that Java string print line works the way it does of concatenation of strings with things like formatters or automatic formatters. So when you do like plus and a double and a plus, it actually formats it as a double. That's kind of the way he prefers to do it. He does a lot of formatting of objects that are providing a append to method, taking in appendable. And you'll see a lot of these type of objects or these type of methods where a string builder is coming in and then you append to that. Append your local string. Which one is this one here? Oh, so sorry. This is the version for string builder, and this is a generic version for appendable. String builder actually implements appendable, so that you can do print stream like appending to a string builder as well as any other source. So he uses appendable pretty heavily throughout his code. The one annoying thing is that appendable declares or throws IO exception. So that even if you're working exclusively with string builder, you're having to handle these IO exceptions throughout the stack, which can be kind of annoying, especially when they can't possibly occur. Because it uses the abstract type of appendable, you don't know that an IO exception couldn't be thrown. So it is a little bit annoying in a way.
We can add something too. This is actually responsible for a significant portion of the memory churn problem that we see in applications.
The string concatenation?
Yes.
Yeah.
String builder or
Yes.
All of the above.
All of the above.
Yeah. So our logger, for example, we have our own logger facade. It's not all that different than SL4J, except that it takes a var args array as a parameter, and rather than having to concatenate everything before handing it to the string builder, it actually outputs the individual strings.
So the only other option is really to do a direct write onto a buffer.
Mm-hmm.
And stuff like that, so you get rid of the behavior. Effectively, what you're doing is journaling, and there's some wonderful journaling solutions used in HFT, like for instance Peter Lowry's Chronicle framework, which really gets rid of all of these problems. You can now log or journal basically at the speed of
That's
hardware.
called Chronicle.
Chronicle, absolutely, GitHub.
I like Peter Lowry's other code, so.
Yes.
Okay. Most people see that a class like double implements number and don't think about it. It's just like kind of a curiosity. James actually deals with numbers as the number class pretty heavily throughout his code. And part of that is coming from the compiler background of wanting to do coercions to the exact type that you want. We actually have a scripting engine in the robotic or in the robot that you can control the robot using a scripting environment. And then it takes the strings that you parse and converts them into numbers. But it might be a double, it might be a float, it might be an integer. And then when you actually try to call a method, it'll attempt to coerce it into the types that are actually requested. I had seen this in the code that he did for the MATLAB on the autonomous vehicle as well. Part of the problem there is that MATLAB wants to deal with every single variable. Literally everything in a MATLAB program is an array of doubles. If you say a for loop, the index of the for loop is an array, a one-item array of a double that's used to index the loop. For x equals 1 to 10. So by using number in the framework, James used that in order to do optimization. So that if he would see a for loop that was indexing from 1 to 10, he would just use it. He would just replace that on the fly with an int, rather than keeping it as a double. We also use number within the Liquid Robotics JSON framework. It parses into number generically, and the actual type can be an int, byte, short, float, big int, whatever's actually needed to represent it. So there's a variety of number types there, but it is kind of odd to just be using the number type abstractly in Java code. I haven't really seen many other source bases that do it. So this is a favorite feature of mine, which is that he uses try differently than, try and finally different than most people. So whenever you start a new block, instead of just making a block, make it a try block. And at the end of that block, you may discover that you have no exceptions to catch and nothing to put in the finally clause. Well, just remove the word try. But if you change your mindset that you should probably be starting every block as a try block, and then only removing it if it's not needed, it will change your perspective on exception handling and cleanup as well. And I thought that was kind of interesting, in that he ends up handling exceptions in most cases very close to the source where they're generated. They don't escape very far. You don't have these long cases where his code generally doesn't have long stack traces where the catch and the throw are very far apart. Instead, they're often quite close together. And I was kind of resistant to this a little bit at first, and I've adopted that style of starting things with a try rather than just opening a regular block. And I've found that in the end, I do end up sticking with a try block more often than I did in the past. I thought it was kind of a useful change of perspective for me. Something to consider. Another one, and this is actually something that if you are a NetBeans user, you'll see in NetBeans 11.2, which is that I contributed a patch to handle this particular case better, where because I'm now, instead of just opening blocks whenever I have a block, like after a for loop, instead I use try. NetBeans and all the other IDEs would format this as for brace with a try inside the brace, and the only statement inside the brace would be the try statement. That's kind of redundant. So I submitted a patch to NetBeans that removes that extra brace layer from control loops and if then else. James was the first person I saw using that style of not adding the additional block layer and just having a bare try. It also works for synchronized as well, that it's already a block. Why add an extra set of braces? I got some more examples of it here. So there's the for loop version of it. And then the if version of it, and then which one's this one? Oh, this is a kind of an esoteric one of a do try, which I like how that sounds. It sounds very British. When you're forced to write that catch finally at the end of the block, having started with a try, you'll find that yeah, that was a good idea to make it a try block rather than just a plain old block. Kind of mentioned exception handling is a little different in James code. He uses throw very sparingly. Oftentimes, very few exceptions escape the method that they're originated in. The main idea is that, so if you have like a glue method where you have multiple overloads of a method that call each other, sure, it'll pass out an exception between the layers. But in most cases, he tries to handle the exception almost immediately. And this, where is it here? Oh, the idea is that he wants to treat the states of the error kind of symmetrically, and he, rather than kind of forcing it on the overall program to handle the error, if it's something like opening a file, he'll return an empty file object rather than throwing an exception from that. And his goal is to have the number of states that the program can be in minimized by this, so that I've never attempted to connect to the site is the same results in the same state for the program as I couldn't connect or as the connection having failed. And that kind of collapsing of the number of possible states that the program can be in reduces the complexity of the overall program. I forgot what else I was going to say about that. Unfortunately, it's been like 4 years since I wrote this presentation, and I've forgotten some of the points that I wanted to make. The general approach that he has to most of the software that he writes is that he wants it to just keep running, is kind of the mantra that he has. And in a lot of cases, people's attitude would be, let the service die, we'll just restart it. In most of the code that James has written, he instead tries recovery at kind of all costs, including if it means hiding a broken window in Hot Java browser. So eventually, the entire device might crash because there's a bunch of hidden broken windows that that have gotten into some state that the program can't recover from. But the user may not notice that. The idea that a browser would stop working at the first failure when one of the alternatives was, well, just hide that window. Seems for a consumer type device or something like that, seems like a reasonable approach to take. We also take that approach in some of the stuff with regard to the robot. And it does lead to this situation of minimizing the number of overall states, clean as you go, and just keep going. And in other cases, there's a possibility that after some amount of time, it might just get better. The error that you thought was kind of critical may be in fact transient. Things like temporary DNS failures or VPN server went down, so maybe it'll be just fine. There was no reason to panic. Is kind of the unnecessary panic is something to be avoided. So, kind of closing thoughts. I've learned a fair bit by looking at James's code. I've also had the good fortune to look at Brian Getz's code and Doug Lee's, and each of these people are very different, approaching very different goals and designing from a different mindset. And there's something to be learned in the code of each of them. Not really any of these guys write blogs about their code or do a whole lot of talking about their design approaches or the decisions that they made in the implementation. Brian would maybe be the kind of one exception, but he generally talks in very general terms about what their goals are in the Java language and what their reasoning is. But I don't think he's ever had a presentation of why the streams implementation looks the way it does. or some of the gritty details that were design factors in that. But the good news is that all this code is out there, and you can go and look at it yourself, and you'll almost certainly learn something. If you're interested in concurrency stuff, the Doug Lee code is definitely worth reading. You'll see that, again, like James's code, it's very idiosyncratic, and it won't make sense initially as to why it is the way it is. Then you'll find the comment buried deep in one class that says, I apologize for this code, it's written in SSA style, which is single static assignment, which is a particular approach to compiler construction. And that he wanted the code, he wanted to know exactly how the compiler would lay it out. So he wrote the code in so that he would know what the compiled result would be. That's not the way most people write code. Your first goal is, I don't want to, your first goal is, I should know exactly what the assembly to be generated is. But it's definitely worth reading and learning from that particular code. Hopefully this was a entertaining talk.
I would say with Doug Lee's code, the lesson you take from it is that single letter variables, not very useful in helping you understand what he's doing, given the underlying things that he's doing are so complex. Anyways, so when I've read his code, the first thing I've done is just basically when I figured out what something is, I just refactor the code.
Yeah.
So the variable names are very...
I did exactly the same, and that was part of my learning process, was naming this thing. And
self-documenting code, I guess.
Well, yeah. Once you convert the single letter character things into something meaningful, then yeah, it does actually become somewhat self-documenting.
Possibly better than bad names, though. They're actually misleading.
Well,
You have a word that actually has some meaning, and that's not what it's actually representing. Q might be better.
There's an argument for that, because that can be factored into the word, with my meaning.
Sure, yeah.
Which might be different than your meaning, so.
Or non-English for non-English speakers.
Or not, okay.
Well, thank you.
Sorry?
Oh, go ahead.
No, I was saying, and Brian, I don't think he writes much code anymore, so.
No, he still does. He's writing a fair bit of the Valhalla stuff in the libraries area again.
Okay.
Go ahead.
Yes, we put our part in our code. What is the most, you start trying to analyze the code of somebody else. What is your first, like what do you go first? What could transmit to you, or what was your process? You started with libraries, with the main component?
Generally, I'll go with some aspect that I think I understand what it's trying to do, and then verify that assumption. And then other parts that I can ignore for now, I'll ignore. Sometimes it's just learning a source base, other times it's trying to solve a particular problem. At the moment, I'm trying to learn the Java C source base in order to implement 2 RFEs that I want for the Java language. And again, it's a completely new experience. I'm not a compiler writer. There's in fact a whole set of terminology about writing compilers that is to some extent a distant memory to me. And then there's a lot of stuff that, well, since I never got a PhD in compiler writing, and most of the people who work on the compilers at Oracle do have PhDs in compiler writing, I never knew. You definitely learn new things right away. If I didn't know that, if I hadn't previously looked at Lisp code or Emacs code, I wouldn't know that the way that they are manipulating lists in the compiler was derived from Lisp. And that immediately tells me something about their mindset and what I can expect to see elsewhere. That, they're using a Lisp approach. I'm going to expect to see folds and cars and other things that happen in Lisp code, and that they do a lot of Lisp or list copying and appending, where the original list is still maintained as part of recursion as they descend down into a source tree. So it starts to become familiar, and then maybe you don't have to fully understand it in order to solve the problem. In the case of one of the two RFEs that I'm trying to implement, I searched for an error message, the actual text of the error message that was being produced, and then found the one place in the entire Java-C source space where that error message was generated, and then just started looking up the stack for how little I had to tweak in order to make that error message go away. And it turned out to not be that hard. The other RFE, it may end up resulting in major structural surgery to Java-C that is beyond my capability. I haven't decided yet. It may require real compiler engineers. We'll see, but it's interesting to do that kind of exploration, particularly, especially with availability of things like GitHub. It's a fun experience. One of the things I did a couple of years ago was there was a Java game called Tribal Trouble, which was a little Vikings versus African natives RTS type game. So you could either play the Vikings or the Africans, and it had been a commercial game for a while, and then it was abandoned and open sourced, but it didn't work. So I had never done any OpenGL programming before. I had never used lightweight Java Toolkit or LWJGL. But I was able to figure out kind of by poking, and I got a little bit of help about what might be wrong with its compatibility with modern versions of the toolkit, and was able to get it sort of working. And then as a project, I did a major refactoring of it using IDE refactoring and then other manual cleanups to convert the source base from Java 1.4, 1.5 era without generics or lambdas to Java 11. And that was kind of a fun learning experience. I think one of the things that made it useful is that this was a game I had liked and played, and it wasn't just a toy. It was actual, real working program, and my goal was, more like car restoration than it was, system or design. My only goal was to get it to be back exactly the same as it was, except modernized. Which ended up being kind of fun as well. So, yeah, go ahead.
You mentioned a bit about using IDE refactoring yourself, but also potentially having had the chance to watch James do this.
Mm-hmm.
He's quite happy using refactoring. I don't know if you can pull any interesting examples of stories about that off the cuff, or just maybe for future iterations.
I'm trying to think. There was one part where he replaced one GIS library that we had that turned out to have a license that we couldn't be using it with another different open source GIS library that had a more favorable license or a legal license. And it was kind of odd because, we had a meeting at like 1 o'clock with managers and execs when we realized that we had a license issue. And James is always an open laptop in meetings kind of person. And by like 4 o'clock through 2 successive meetings, he had like Googled around, found a library that was compatible and done all the refactoring work and said, problem solved. What do you mean? We're just starting to get going on this problem. No, I replaced the library. But it's not a problem anymore.
Very productive meeting.
Yeah. So the meeting was, very productive. But I haven't, he's not a person who does pair programming, so I haven't really like watched over his shoulder to work with him in that way.
I guess maybe comments about the short hair thing. I was curious if maybe he had started with long names and it was his pattern for.
Well, the one thing that he does do is that in his math libraries he uses Unicode variable names. So he uses math symbols as variable names in his code, and that's odd when you first see it. It's like, why is there a theta in the middle of this code? Hey, that actually works. And if you want to, you can make smiley face a emoji a variable name. And I don't recommend it, but it seemed appropriate in that case. I mean, elsewhere, he doesn't use like Doug Lee's 1-character variable names, but they're generally very short and pithy. But since he doesn't write long functions for the most part, it's not a problem because you don't lose the context of what that thing is for, and they're not like 1-character field names unless the field name is like the X coordinate or something like that. Cool. Any more questions? Okay, thank you.